Hi, this is my project from Programming to Prognosis, affordable and portable retinal health assessment tool. So how does it work? So right here you can see my training program, and this is what trains the machine learning model, and it creates the file that allows the main program to be able to actually detect the different types of eye diseases. So here you can see I am pre-processing each image to a standard size and a standard color. And then what I do is I categorize the images. So I have a different directory, a different folder for each of these images. And then once that is done, I organize the images, each one into these subdirectories. And now after this step, my next step is to generate a training and testing split. So my goal is 80% training and 20% validation sets, which is what you can see here. So it splits the images in each of these into an 80% train, 20% test. Once that's done, it'll print that the sets are generated. This is to make the process even more user-friendly for anyone who's using this. Then it starts to train the model. So how does it train the model? We go through a convoluted neural network through 32 different layers, and once it does that, it trains till it gets a required accuracy. Once that accuracy is done, it saves it as the model.h5 file, and it also saves a second file called labels.txt, and you'll be able to actually see that in the top left corner of the screen up there. And what the .h5 is it basically saves this huge convolutional neural network into a very small type of file that can run on any type of hardware. It's very easy to run. And the labels.txt allow it to convert what the model did and found out in your image to the actual label. So now this is the real code. I use Tkinter here for the graphical user interface, and what that allows me to do is basically, instead of having a code-based or command line interface, it allows me to instead have a graphical user interface which is easy for everyone to use. So it loads the model that we had just trained, the keras model.h5, and then basically it asks to enter the name and select the image for analysis. Once that's done, I have many different types of error loading procedures that basically try to account for any types of error and let you know what might have gone wrong. And then once the image has actually been uploaded, it runs it through this machine learning model, which has an extremely high accuracy. And once it's run through the machine learning model, it generates the label and it tells you what it is. So let's go ahead and try to run this now. So as you can see, I'm typing in the command python main.py, since the program's name is main.py, and this is all you would have to type. Then, as you can see, it starts by first loading the model, which is what it's doing right now. And the first time you do this, it does take a little bit of time, but then after that, it does this almost instantly. Okay, perfect. So now you can see the instructions have popped up, and here it says enter a name and select an image for analysis. So let's go ahead and do that. And this is what I meant by graphical user interface. It's in a way that doesn't require any code information and you can easily do. So I'm going to enter the name student for now, and I'm going to hit OK. And now these are all pictures that it's never seen, and these are of glaucoma. So these are different retinal scans for glaucoma, and they are images the model has never seen. So I'm going to go ahead and choose one. So for example, let me go to that one. And then this is the really cool part. It's based on everything it's learned through the 32 different modules of the convolutional neural network. It's able to actually predict it, and it did it correctly here. It said predicted condition glaucoma, and it was able to give advice to go see a doctor with 100% confidence. Thank you. This program can help solve a real-world health problem, shortage of ophthalmologists, by detecting various common eye disorders and preventing blindness.